Hello, I am Pete Demar with Battery Research and Testing, and I will be narrating this session of our stationary battery maintenance tech tips. This is tech tip number 5, understanding open circuit voltage readings with lead acid cells. We all have had to replace a cell or a unit in a battery string. How can we know that the new cell or unit is not partially discharged when we install it? In this tech tip, we are going to explain how by just measuring the open circuit voltage of a cell or unit, you can determine if it is in a discharge condition or if it is ready to be installed. But first, some COA statements. First, if you do not know how to safely work on stationary batteries in either energized or off-charge battery systems, do not attempt this. Second, if you do not know what the proper PPE is and use it, do not attempt this. Okay, back to the tech tip. It is well understood that if a discharged cell or unit is installed into an existing battery string, that it may never become fully charged under a normal flow charge, or in many cases, not even if the string is given an equalized charge after it is installed. This could mean that your new replacement unit could be the weakest one in your string. Any replacement cell or unit that is being installed into an existing string should be in a fully charged condition before it is installed. But how do you know if it is partially discharged or if it is ready to be installed? If you do not know how long it's been since it was last charged, or the conditions that it was stored in, or even if you just received it today and plan on installing it tomorrow, how can you be sure it is ready? Just because it is new to you does not mean that it is not partially discharged, or that it is ready to be installed. Just one voltage measurement will tell you if it is in a charged condition or not. The universal rule that determines the open circuit voltage of any lead acid cell is the total of the specific gravity of the cell plus 0.845. Open circuit voltage is the voltage of a cell or unit that has been off charge for an extended period of time. Think a couple weeks minimum here. This is just an approximation, but a cell that has been on charge and then taken off charge requires some amount of time to lose the overcharged voltage that had been applied to it. To determine what the open circuit voltage of your cell is supposed to be requires that you know what the electrolyte density, the specific gravity that your cell or unit was filled with when it was manufactured. It usually will be on a sticker on the cell, or you can get that information from whomever you purchased it from. To assure that you are calculating the correct open circuit voltage, do not, I want to emphasize that, do not measure the specific gravity of your cell and then use that number in this calculation. The reason to not use that number is that if the battery is partially discharged and the specific gravity has lowered, then it will provide you with an erroneous anticipated open circuit voltage. Only use the specific gravity value that is provided by the manufacturer for this calculation. Some examples of correct open circuit voltages for different specific gravity cells are as follows here. As you will see, as the specific gravity goes up, the open circuit voltage goes up. And that 1300 to get to 2.145 is usually used for VRLA cells. Now let's say that the single cell that you're going to install has a measured open circuit voltage of 2.02 volts, and the nameplate specific gravity is 1210. Not bad, right? You get a good cell. No, that cell is partially discharged and surely somewhat sulfated. To do this in reverse, there's also a calculation you can use to determine what the specific gravity is in a cell when you know the open circuit voltage. It is just the reverse of the previous one. If you take the open circuit voltage and you subtract that 0.845, it informs you of what the actual density at that moment of time in that cell is. Here are some of those calculations, some examples. Obviously, if you were working with a 3-cell or 6-cell jar, you just multiply any of the above values times the number of cells in the jar you were working with. Any voltage that you measure that is below the correct open circuit voltage for its published specific gravity value means that your cell is partially discharged. The lower the open circuit number you have, the more discharged it is. To fix a cell before you install it, you will need to boost charge it. Every manufacturer has instructions as to how to perform an initial or boost charge to their cells. Check with your respective manufacturer. For a boost charge to accomplish what it is designed to do, it must be performed properly and completely. Do not take any shortcuts when doing this. This is important. The basic initial value that we use is typically 2.4 to 2.45 volts per cell. That is dependent upon the cell, specific gravity, and what we find. Of course, all of the voltages that we use in this tech tip are based off of a standard cell temperature of 77F or 25C with adjustments as needed. If for some reason you must install a partially discharged cell into a string, then you can go ahead and do it, but you will need to use a single cell charger to give it the boost charge needed once it is installed. Otherwise, it may never come around. For info on how to boost charge an individual cell in an online battery string, if you are not familiar with that procedure, check out tech tip number 6. Hopefully, this explanation will help you understand if your replacement cell or unit is really ready to be installed into that string or not. If you are interested in understanding more about what we do or might be able to help you with, or for pricing on one of these HP Max shop chargers, please go to www.batteryresearch.com and look around, or give us a call. If you would like to be notified when we release a new tech tip, please go to info@batteryresearch.com and tell us to notify you when we release a new one. Or if you just have a question on a stationary battery subject, just do the same. Oh yes, if you have any experiences or pictures of unusual things that you have found, please share them with us so that all of us in this industry can benefit each other. Have a great day, stay safe, and stay healthy.